Hello, my name is Dojik and this is my Physics 102 lab project. In this experiment, my goal was to calculate the magnetic permeability constant and observe how the magnetic field changes with distance and current. I built three main setups using copper wire, nickel wire, and a solenoid. The first setup used a long, straight copper wire. Initially, I faced a short circuit because the resistance was too low, so I added a 150 ohm resistor and shortened the wire to 35 centimeters from 2.5 meters. This allowed stable current flow, and I observed the magnetic field decreasing as I moved away from the wire. As expected from the formula, B is equal to nu 0 I over 2 pi r. Next, I tested a commercial nickel wire. While pure nickel is ferromagnetic with high permeability, my results matched the permeability of free space, suggesting the wire was likely a nickel alloy with low magnetic properties. The error in this setup was very small, just around 3.6%. However, because the magnetic field in these straight wire setups were weak, measurements accuracy was difficult. After consulting with my teaching assistants, I repeated the experiment using a solenoid to produce a stronger magnetic field. Although the solenoid setup improved the visibility of the field, the error was unexpectedly high, over 500%. I investigated this by measuring the actual current in the circuit and found that the power supply readings were misleading due to low precision and small currents. And these are the results for the solenoid. Several external factors may have contributed to the error, including interference from the other experiments in the lab, small displacements during measurements, and possibly the use of a phone-based testometer app, which may not handle small field changes accurately. Another key issue could have been the incorrect use of the magnetic field formula for the region outside the solenoid. Overall, while the straight wire and nickel experiments provided reliable results, the solenoid setup highlighted challenges in experimental measurements and power supply limitations. These factors are important considerations for future experiments on magnetic fields and permeability. And these are the graphs derived from the data in the tables that visually show the magnetic field behavior. Thank you for listening.